Okay, so on Tuesday we covered zip. We went over something that was about. We looked at basically the frequency of word occurrences, right? Remember that? Yeah, I'm just getting started with this. We've got plenty of content to go through today. So we were looking at the frequency of word occurrences and how often words occur in just the English language in general. And counting the frequencies of things as they occur is actually a very common task. For instance, like figuring out the letter frequency, which is going to be the focus of a bit of today, the first part today, is the frequency in which letters of the alphabet appear in a language or in a text. So, for instance, as you're probably well aware, E is the most common letter in the English language, in English text. Here's the frequency count depending on whether or not you're just going over a big amount of text or if you're counting every word in the dictionary. We find that E is the most common common letter, followed by A. You can remember it with itoin, ida-o, or ida-on for the most common 5 letters. So rather ET than A. But again, it depends on which count you're using. And so why is this important? Well, aside from like getting on a game show like Wheel of Fortune, right, where knowing letter frequency is pretty good, essential for making good guesses for letters, right? You don't want to guess Z or X, those letters, or Q especially. You just assume where it is and try to solve it. Let's see. The frequency of letters in text has been studied for use in cryptanalysis and frequency analysis in particular, dating back to the Arab mathematician Al-Kindi, who formally developed the method. Ciphers breakable by this technique go back at least to the Caesar cipher invented by Julius Caesar, so this method could have been explored more in classical times. Yeah, we don't know how long basically people knew this, but basically you realized if you had long enough text and you knew it was very simple encryption, you could simply say, okay, the most common letters in E is probably E, or T. Let's go from there. Okay, and start trying to decrypt from there. Also know that the language is in English. If we're still talking about English, you know that ETH is probably the most common pair. So if you're counting letter pairs rather than just letters, you can figure that out. So it's very important. It's also part of the importance of like figuring out. And part of cryptography is masking this. You want all symbols to be basically as equally viable as any other symbol in cryptography. You don't want people to be able to try to attack your cryptographic algorithm via this a frequency count. So how do you do a frequency count anyway? That's the focus of today. So I have this task, and you don't really have to follow. You don't have to follow along on your computer. Just follow along as I type, because I'm going to use the Dracula file again, just because that's what I have on me. We have Dracula.txt. How do I find out what the most common letter in Dracula is? Right? How do I do that? Okay. So open Dracula.txt. Read equals. Let's see, the file, and then we'll just simply say for line in the file. Basically, I want to then count how often each letter occurs in the line. Okay, so for line in the file, for each letter in line, and then that's where we kind of get to. ask, okay. So what are the letters of the English alphabet? They are A, B, C, D, E, F, G, H, I, J, K. You know them all, right? So let's see. Is there a way that Python gives this to us? String letters, Python. I think it's alpha. Oh, actually, I forgot. I can just test it over here. I always forget about that. No, I don't want to talk about the arsenal of mysteries, the terrifying allure of a remote Caribbean. No, I don't care about that. Wow, Explorer just crashed. Great. Good job, Windows. Okay. So let me go with dot alpha. Is that how I can do it? Okay, yeah. Okay, yeah. If letter dot is alpha, which would let me know if it's an alpha numeric character. Print letter. What do I mean by that? Let's just go ahead and run it. All right, let's go ahead and put this in desktop, and I'll call it freak and dict. Okay. Oh, right, I have to do this, right? This is the reason I said, you know, you don't have to follow along on your computer. Encoding is equal to UTF-8, right? So we go ahead and run this, and notice that it's printing out basically letters. We're not printing out any spaces, not any punctuation marks. We're just printing out letters, some of which are capital, some of which are uppercase. So daily, graph, August, chapter, VII, so 8, right? So I stopped just at chapter 8. But basically, what I'm saying is 4 line in the file, 4 letter in the line, if it's a letter. Right, do this. I printed it out. So now so here I've gone from for every letter in the file, so we've got the entire file. Then I go for every line in the file, and then I say for every letter in the line. Make sense? So I've went from file to line to character. Okay. And what I want to do is I want to count up each letter and say, hey, is this, how many times does this letter occur? Okay, so how do I keep track of 26 different letters, right? So first off, there's like kind of the brute force approach, right? Which is A is equal to 0, B is equal to 0, right? C is equal to 0, ... right? Do for, y is equal to 0. Everybody get the point? Okay, 26 different variables. And then what I do is as follows. I say 4 letter in line, letter is equal to letter dot lower to make it lowercase. So now all I'm dealing with is lowercase letters rather than uppercase letters and lowercase. So they're all the same, right? So I'm just converting everything to lowercase right here. Okay? In fact, actually, that might be a quicker thing to do with the line, but whatever. Yeah, it's probably a quicker thing to do over here instead. And instead convert the entire line to lowercase. Line is equal to line.lower. Great. And what we'll do, and now instead of doing this if letter is equal to alpha, what we'll say is if letter equals A plus equals 1. Elif, or I mean it's just going to be 1, but it's good practice to do elif. Letter equals. I'm erasing this soon, so please do not try to keep up with this. This is because this is useless code I'm writing here. Right? B plus equals 1. And then if the letter if it wasn't a B, what if it was a C? Right? You get the picture, right? All the way down to Z, right? And then I can, instead of typing it, maybe I can speed up the process it by, just doing copy and pasting. But again, we kind of just do this all the way down to Z. This works technically, but it's like that looks, you know, you've probably seen the meme about the program that does addition by hard coding every addition operation as an if statement, right? If it's 1 + 1, then the answer is 2. If it's 2 + 2, the answer is 4. You know, so hard coding all those operations, those addition operations. And you end up like with a 2 million line file as a result. It's nobody actually writes a 2 million line file. Instead, you write this may be a new concept for you to think of, but you write a program that writes a program with the text inside it being the code you want to run. And it's fairly easy to do it for something silly like an addition program. Anyway, so this obviously is a bit of a lot of work, right? It's a nasty amount of work, right? To keep track of a lot of typing. There's an easier way to do it, right? Though we've kind of brushed up against it before. Instead, I can use a list, right? Counts is equal to this, and then I can assume, you know. What I can do is I can create a list of 26 zeros, okay? One for each letter in the alphabet. Assume index 0 is A, index 1 is B, index 2 is C, ... Right? Makes sense? So we've got 26. Does this make sense to everybody? Did I lose people here already? I make a list, all right, of counts. And what I have this basically, I basically have this thing, but it's 26 zeros. And index 0 is going to hold the number of the number of A's I've seen. Index 2 is going to hold index 1 is going to hold the number of B's. Index 2 is the number of C's, and so on and so forth, until index 25 is going to hold the number of Z's. It's in order, so it's easy for me to remember. Now, how do I figure out what I'm doing? Instead, what I ask is, I'm going to go ahead and do what I was doing earlier, which is I'm going to say if letter dot is alpha. In other words, if it is an alphabetic character, right? In that case, what I'm going to do is I will figure out which index I'm adding to. Okay, how do I do that? A few weeks we learned about when we were doing cryptography, we learned about the ORD operation. And what we'll do is we'll take the ORD of the letter, basically the numeric value of the letter, right? Remember, everything's in computers is a sequence of ones and zeros, which means that everything is a number. So we take the numerical value of the letter and subtract A from it. Letters start at the number 97, just because that's the way it works. That's the way it works in ASCII. Letters start at 97, so A is 97, B is 98, and so when we subtract A, that moves it from the 97 and up range to the 0 to 25 range, right? We're subtracting that 97 starting point, so everything now starts at 0. So what we do is so if it's a letter, we figure out what index we want to do, and then we say the counts of that index plus equals 1. And now that code is a lot shorter, a lot shorter. And now we can say, for in range, so let's see, for I in range 0 to 20, 0 to 26, print counts of that so we're going to print out what's being counted at that, the amount of times I've seen that letter, and let's just give ourselves a visual guide to know what it is. So we know it's A, B, C, D, E, F, G, and what I'll do there is I'll simply say ORD of A plus I, so it starts at 97 plus 0, then 97 plus 1, then 97 plus 2, 97 plus 3, and then I'll convert that into a character. Again, you don't have to, it's a lot of, by the way, that's a lot of tricks just even thinking that out. Index is out of range. What index was out of range? Tell me what index was out of range. Counts plus equals 1. What index was out of range here? Or index is equal to word letter. Okay, print index. Print letter index. So let's go ahead and see. We got to a point where it says it was out of range, which is very interesting. For a letter, we shouldn't be getting that out of range issue. Seems to be going just fine. It's keyboard interrupt print letter. I mean the 26 should be exclusive. Sorry, so it's right. The indexes are 0 through 25. And this is 0 through 25, so again, I'm not sure what's going on there. What is it croaking on? Try. Oh, I don't even know how to do this in Python. I know how to do it in other language. Try, or I forget how to do this in Python. Except let's see. Okay. Apparently those are alphanumeric characters. That's what's going on. Apparently this one is alphabetic too. Let's go ahead and look at string is alpha maybe to see if there's something else that we would better find. Python docs, built-in types. Is alpha num string alphabetic properties defined in Unicode? It's going by Unicode definition as opposed to being, let's see. So that's super useful strings. Does that mean I have to do the annoying thing? Are you saying that I have to do the annoying thing, which helps make my point even more about how much of a headache this is? Right? So let's go, I think it says so. So in this case, what I'm going to do is I'm going to say valid letters, and I'm rather than doing A, E, A, B, C, D, E, F, G, I'll have this, and instead what I'm going to do is I'm going to do valid letters dot append. This value. And then instead of asking if it's an alphabetic character, I'm going to ask invalid letters. The code is getting messy and hard to read. What does this do? It says, again, 97 plus 0, 97 plus, and then it turns it into a letter. So let's go ahead and see, do we get any issues anymore? No. No issues anymore. Instead, what I can do is I can print out valid letters, instead over here, valid letters, okay. Here we go. And we can, so here's our letter count anyway. So we look through every letter, asked if it's in the valid letters. If it is, we figure out what index it is, and we add this. There we go. A occurs 5,000 times 50,000 times in the document. B, 9,000. J, a mere 900. Z 282, but E occurs a whopping 81,000 times. It's very, again, much more, it's very common a letter here. So it's not impossible to do this task. But now I make one change to the problem and it becomes a real kind of awful thing. This I'm asking for the most common character here. What's the most common word in the file? Probably the, but I mean like, what if I asked for the top 10 most common words? How in the world would I do that? In the world do I find out what the most common words in the file, what the most common word in the file is, or the most common ones? So let's go ahead and just go ahead and just kind of toss this all away because it's useless now. Okay. Except for this bit. This bit's good. It can stay. And that bit. Saying given the file, for every line in the file, turn the line into lowercase. It's going to be that's basically the only useful bit in this. How in the world do I find the most common word? Well, this entire thing where I created a list, that only worked because I know in advance there are 26 letters, and I know what the letters are going to be. So, like in theory, based off of what we know, and it's assuming we only know about lists, and lists are the only things I could do. I could read through this list once, and what I could do is I could do line.split. Okay, line.split, which will split on spaces if you don't give any arguments. And I'll just simply, and basically because spaces are what separates words, right? Make sense? Spaces are what separate words. So, and then what I'll do is that this is what I'll do. I'll have like a list of the words is equal to an empty string, and for word in words, if word not, instead of calling it the words, I'll call it seen words. If word not in seen words, even my attempt to make variables easy to read is suddenly becoming a nightmare here. With the words, and seen words, oh no, for word and not in, I've not seen the word yet, seen words dot append. So I can read through the file and find out what all the words are, right? Okay. And what am I appending? I'm appending word if I've not seen it yet. And then after I do that, let's see, for line in file, let me just go ahead and, so let's go through the file again and print out the line. I'm just going to double check if this even works. Invalid syntax. Not in. I forgot not in. Seen words. And, okay, so two things happened there. One, did you notice how long it took for it to read through the file and generate the list of seen words? And second, when I tried to read through the line, through the file again, you just can't. You have to reopen. I think what you have to do is essentially you have to reopen the file to read it again. What a pain, right? So there's the seen words. So I've seen all the words I can. Let's try opening up the file again, and now I can read through it again. So I had to open it up a second time because once you're done reading the file, you're done reading the file. And then what I can do is I can do the same thing over here. And then what I do is I do the same thing over here. Okay? blah, blah, blah. Get the line, split the line into words. And for each of the words, well, we know it's going to be in seen words because we've seen it. Instead, what we do is we get index is equal to, so instead what we need to do is now we do counts is equal to a number of zeros equal to times the, 0 times the length of, yeah, don't worry about if you're not following any of this. This is something I've never tried before because it's that bad. I know not to do it. This is terrible. You should never do this. This is awful. Seen words. Okay. The for line in the file. Line is lower. Words split the words. Now what I do is now that I've counted all the words, I'm going to go through the file again, and I'm going to say, okay, if I see the file, I've got a count of that now. I've got I've got a list to count everything in now. So list index is equal to seen words dot index of word, and then that will tell me to counts plus equal, counts of index plus equal, and then for WC in zip, again, have to do the zip operator. There's no way to go about it without the zip operator. Word, seen words, counts, all right, so it's going. That'll take forever, assuming I didn't mess up somewhere and it crashes. Probably did mess up somewhere too, but it's going to take forever for me to find out. Oh no, I didn't mess up, and now it's printing out all the words it's seen. So I was able to do a word count of all the words it's seen, except what's the issue? I was looking for the 10 common most words. That was what I initially asked. Most common 10. You think you can find it in this list? It's going to be a bit of a pain, right? I'd have to find the max and then the second max somehow, and it's a mess. But there is one important thing over here. Basically, there was a map between the index of the word and a mapping between the word and the index of the counts. So instead, this just doesn't work that well. Okay? It's painful to do this. It's really, really, really painful. So painful that this is the first time I've done it, and I hate it like that. Instead, I use a different tool for this. Okay? Instead, we have this wonderful, wonderful tool to never do this. It's called the dictionary. Okay? Dictionary. So in other languages, you might call it the associative array. Formally, in most languages, it's a map or hash map. You'll learn why it's called a hash map in 2168, but that's because it uses hashing. In Python, it's called a dictionary, or often it's referred to, dictionaries are often referred to as a dict for short. So you can go ahead and giggle for like 5 seconds, but the dictionary is a very powerful tool. Okay? And the way you create a dictionary is actually very useful. I'm going to say D is equal to, and then use those two keys. What are those two keys? Well, we call this the curly braces. Okay? Let's see. Yep. The curly braces are those key. So you're only going to really use these if you're in programming. They're the ones that are that on a standard English keyboard. They're on the brackets, and they're what you get if you hold Shift on the brackets. That's a dictionary over there. But what the heck is a dictionary? Well, formally, it's an arbitrary mapping between any two values. Specifically, it's an arbitrary mapping between any number of keys and values. What do we use it for? A number of things. We use it to basically for translation, dictionary. We use it for counting arbitrary numbers of things. We use it for categorizing. We use it for key-based lookups. So given a customer, give me all the information on that customer. The dictionary is, if you're a fan of Doctor Who, it's essentially the sonic screwdriver. It does everything and more in things you wouldn't even expect. Okay? It's great. It is our all-purpose tool. It does tons. If you're stuck in an interview, in a programming interview, see if you can't use a dictionary to help hack your way out of it. It is an extremely powerful thing. But what do we do with it? I just told you what we can do it with it, but that doesn't. But how and what? What does that actually even mean? Okay. So let me open up a Python shell and just interact with it like this. Let's create a dictionary. So a dictionary is, and one of the reasons I teach it in this class is because it's so easy to use compared to other languages, because you get to use almost everything you learned about a list to use it. To start off with, think of a dictionary like a list, except you get to make up your indexes. You can make the indexes be anything you want in any order you want. So D of 2 is equal to, D of 2, I accidentally hit space before I enter before I finish that, is equal to the string 2. D of 3 is equal to the string 3. D of 4 is equal to the string whatever, because why should I follow a pattern that's predictable? And so if I print out D, it shows that basically that we've got these 3 bindings in here. 2 goes to 2, 3 goes to 3, 4 goes to whatever. Okay? And let's just go ahead and do one more. 10. Just because, it doesn't matter. Actually, let's go with blend, because end might imply something that we're done. We're not. So 2, 3, 4, whatever. So 2, 3, 4, 10. 2, 2, 3, 3, 4, whatever, 10, blend. Okay. Now, so this over here is roughly referred to as the put operation, and the other operation that we're about to use put, obviously, because we're putting something in a dictionary. The other operation is get, where it's just like we would use with a list. So I ask what's associated with what is associated with what's bound with the key 2. It's keys as opposed to indexes. What's associated with the key 3? 3 is. What's associated with the key 4? 4, whatever is. What's associated with the key 5? Nothing. I get an error because I didn't bind anything, right? Remember, they can be whatever I want. The keys can be whatever I want them to be, right? Make sense? So it says, given what you do when you put something it says, when you ask for a 2, I'm going to give you 2 back. Whenever you ask for a 4, I'm going to give you the string whatever back. When you ask for the number 10, I'm going to give you the string blend back. If you ask for something that I don't have, that's not in our defined keys, I'm not going to give you anything. I'm going to give you an error. Right? Similarly, like no 1, because we didn't define 1, no -1, that's fine. So, also importantly is that it doesn't work the other way around. If I do D2, which that looks weird because you shouldn't be able to do, in list you can't do that. oops, sorry, D2, I had it highlighted and I hit enter, and that had unfortunate side effects. But it doesn't say that you can't use a string as you can't use a string as a key. It just says key error. You can use strings as a key. I said that the keys can be whatever you want them to be. So I can say something like this: D, apple, red, D. Actually, let's go ahead and start a new dictionary, okay? D, apple, is equal to red. D, banana. Sorry, the difficulty with spelling banana is not spelling it; it's stopping spelling it. So that's Terry Pratchett, by the way. So there you go. D banana, D apple. So color, obviously, I'm going for here. D orange. Okay, is equal to orange, right? Oranges are orange. And D, and one last one, lemon, because I wanted to throw something else that's yellow in here. Okay. And yes, I know not all apples are red. We're just going with that. That's a deliberate choice on my part. Okay. So if I printed this out, we get the key apple is associated with red. So that's the way to read this. There's a colon that separates the keys and the values. So the key apple goes to the value red. The banana goes to yellow. Orange goes to orange. Lemon goes to yellow. Okay. So first off, notice that it's possible for two things to have the same value. In terms of like if you remember from algebra, this is a many to one function. You know, you can do many things, and each of those, and any of those keys can go to many of those keys can go to a single space. Is that how it works? I don't really deal with that, but you can think of them in terms of functions. That's what they are. They are maps. They are mappings. But it is one way. Again, right? I cannot ask what is yellow. That's not a key. It doesn't matter that's in the values or in the value twice. It's not a key that I defined. Okay? Makes sense? Not a key I defined. Now, it's okay to have two values that are the same thing. However, if I do this, D, apple, whoops, D, I don't know why I'm having so much trouble typing today. Apple is equal to green. Okay? Notice that what happened. We've went from apple is red to apple being green. A key can only have one value associated with it. So if you use it, if you do this again, it's just going to if you do a put operation on a key that already exists, it's going to update the value. It's going to replace it with whatever the new value is. So this is useful because that means that if we associate with a key with a number, we can increment that number. Okay? So and suddenly the problem we have becomes really easy to deal with. For instance, and we just need a few more things to do. So we have a get operation, we have a put operation. Now we just need actually one more thing. Seeing if something's already in the dictionary. So let's go ahead and ask apple in D. True, the word apple is in D. Lemon in D, right? That's a key. Yellow in D. False. So the in operation checks the keys, right? It checks if we've seen a key. The keys are the most important thing, right? So that allows us to check if something's in there, or I can say something like durian not in D. True, right? That's not a key in there. So this so put, get, and in. These are the three tools we need. Okay. So I still am working out when the date. It's at least 2 weeks. At least 2 weeks away. You're not going to have an exam until either April. It's either going to be April 5th and 8th or April 12th and 15th. Don't know yet. It's going to be one of those. Probably the latter one, just so I can make sure you've got plenty in there, even though that's closer to the end of the semester. But here you go. Here's one question I'll ask you. Here's a string. What is the most common word in this string? And we're about to solve something a lot like that right now, where instead of a string, we've got a file, right? Given the most common word in a file, it's possibly the most this is word count. One of the most common applications of a dictionary is counting things. Specifically, we're counting things and we don't know what the things are we're counting in advance. Like we don't know what each of the words are in advance. We don't know what each of the characters are necessarily in advance, right? We don't know in advance what we're counting, but we're able to keep track. But we want a way of keep track of them. So let's go ahead. So instead of doing a counts as a list, we are doing a counts as a dictionary. So now we do the same thing we were doing. 4-line in, and yes, this is kind of walking to running, like super quick right here, okay? 4-line in the file. Right? We're going to still put it to lowercase, okay? Line is equal to line not lower. So again, on the exam, it's going to be something like, give me a word, given a file, return the frequency at which each word occurs, or give me the amount for each word, give me the amount of times each word occurred. Here I'm asking for like the most frequent word or the most, or the least frequent one. So for line in the file, make that line lowercase. Words is equal to words dot split. Sorry, words is equal to line dot split. Then for word in words, right? So what did we do? We went through and we said, okay, we iterate through the file, go through each line, split it up by spaces because we know words are separated by spaces. That's how words are separated in English text. And then we're going to go ahead and say the following. If word in counts, or rather, if word not in counts. Let's go from that logic. It doesn't matter which one you start with, but let's go with this logic first. If the word is not in counts, if it's not a key yet, that means this is the first time. It means I haven't seen it before. It means it's the first time I've seen this word. So if that's the first time I've seen the word, I'm going to say the counts for this word is equal to 1. It's the first time I've seen it, right? Make sense? Okay. If I've not seen it before, this is now, I'm going to put it in my dictionary and say I've seen it once. Very simple, right? Then I'm just going to follow it up with an else statement. So if I've not seen it, then the else is I have seen it, right? If it's not in counts, if I've not seen it, the else then has to be else I definitely have seen it. Counts word plus equals 1. So for every word, if I've not seen it before, I've seen it once. Otherwise, change the number of times I've seen it by 1. Definite? Yep. And then that's it. 1 second. And then it squeezed out the text because it's a bunch of text. Yeah, sure. And then there's all of that. There you go. That's a count of all the words. There's a couple of issues here, like with like non-numeric characters and punctuation still being in there. That's a pain. But that's a different. But we'll solve that We'll solve that at a different time, right? Okay. And they're kind of negligible to figure out what the most common thing is. Like we can tell that have occurs 1,051 times. To occurs 4,505 times. Then if issues with punctuation again are going to be negligible. And we can handle them in different different thing. I had to crash. I just needed to do that before I can get it into more of a kind of useful format. Also, notice that it went relatively quick, especially compared to doing this. So, in terms of big O, if you know what that is, each of these operations over here, checking to see if it's in a dictionary and then adding it to the dictionary, is what we call a constant time operation, meaning that no matter how big the dictionary gets, it always takes the same amount of time. It uses magic to do that. Cheating, actually, is what it does. It cheats to do that. And the cheating involves wasting basically 100%, basically an extra 50% extra space required than you would for a list. It uses up extra space to cheat, essentially. That is the short answer for how it does that so fast. As compared to this, where checking to see if the word was something I'd seen already in a list, that takes what we call linear time, where basically that is proportional to the amount of things currently in the list. So as the list got bigger, it took more and more time to see if it was in the list. This thing cheats. It takes the same amount of time as whether there were 10 things in the list, or whether there were 50 things in the list, or 5,000 or 5 million. It cheats to do that. It cheats by using hashing. How does it cheat? You got to wait till you're at 2168 to see that, or you can just go to the YouTube channel I have set up if you're really curious, right? Give me 1 second, because let me get to the proper account, the one I use for school. Switch to Professor Rosen. You're really going slow on me, YouTube. I know it's because you don't like me using Firefox. I know that's the reason. Okay, your channel. So go to my playlist. So if you're really just dying to know why that is, you can go to my playlists. So on the channel where I've been uploading everything, and I've got tons of playlists from everything. If you're dying to know how it works, go to the 2168 and specifically go to week 10 hash tables in 2168. That's where I cover it. So if you really need to know, that's where you learn it. But you don't need to know how it works yet. In your 2 classes before that. Just know that it does work fast, and that's kind of great, which means it's really versatile and useful. And look how much shorter that code is and how much more it made sense, right? If it was something I'd seen before, great. If it's something I haven't seen before, I'd say I've seen it now. And if I have seen it, increment it by 1. That's how you count things. And we don't have to define anything in advance. We don't have to do any of this nonsense over here. We can grow kind of organically, and we only have to read the file once. Okay? So how do we do, basically print out only like the top 10, the top 10 things I've seen the most of. That's a different question, unfortunately. So the way we do that is I always forget, and I know it involves sorting. So print, but I always have to look it up, so don't feel bad if you have to look it up. Print out dictionary Python in reverse sorted order. Now, reverse sorted key, no. Reversed, really? No, that's just the keys. Print out dictionary Python by values in reverse order. You can see that's a very common operation to do. Okay. No. Really? Ah, there we go. So, you always have to look it up. For key, so basically it's to start, how do you print out everything in it? So I should start from the beginning. How do you print out everything in this? For key in let's see, in counts. For each key in counts, we could just simply do this, print the key and the amount of time it occurred, counts of the key, right? Or maybe that will make more sense if I just simply say, rather than K, word. For every word that we counted, print out the word and the amount of times we counted that. And again, we get into this where we're printing out all these values, right? Let's go ahead and stop that. See, had 1020, late 30. So for every word, so when you iterate over a dictionary, by default, you're iterating over all the keys, right? So instead what we want to do is print out everything basically in order like this. Let's see. So let's go ahead. I think I already actually have it somewhere. So let's go ahead and see. Just quick. Dictionary, sorry, documents, GitHub. Classroom. Like, this is one of those things that I do have to look up each time. It's annoying. Old. Really? Oh, old. I just got lazy and threw it in there. Let's see. Track count. Was that it? Yep. There we go. That's what I needed. Yeah, sorted to the rescue. That's what I thought it was. That was easier than trying to figure it out on my own. So what is sorted? Sorted gives, here, it's pretty straightforward as to what it does. I mean, like, if you think about it for a second, right? If I give, sorted's just kind of built into Python, and if you give it like 1, 2, 7, 4, 9, 1, it's going to give me 1, 1, 2, 4, 7, 9. It's going to give me an sorted. You can also do something like this. You can also do this. You can say, hey, here's the thing I want to sort, and I can say reversed is equal to true. Sorry, I just have to juggle a lot of languages, so it always I have to remember specifically. Reversed isn't not a valid argument. Oh, reverse. Not reverse. See what I mean? Reverse. So there's no shame in like for these like small for these smaller operations to like figure it out. So here I said reverse true. I added reverse true, which gives it in reverse sorted order. Make sense? Now that brings this to this. So sorted count key says basically how do I want to sort this? And I want to sort this based off the get operation. So for every key, so for everything stored in count, right? Typically we're iterating over count, but for every word, I want to sort it by what the value is with it. That's what the count.get does, because get is what you do to get a value, right? So just remember this for magic for when you're doing your, or refer back to this video for magic when you're looking at doing the pig homework. But now, let's see, sorted counts. And Control C, just stop it. And you'll notice as we're printing through it, went too far up. That as we've gone through this, we have printed out basically, as I scroll up, the numbers are getting bigger. The and to I of he and that was it, right? So that does that for us. And now I can just use the last bit that I didn't copy over, which is slice notation, right? Because this gives me, because what sorted does is that gives me a list of, it gives me a list of words, right? It sorts the words for me. And then I can just simply say, hey, for that word, go and reference it by that. And there's our 10 most common words and how often they occurred. So the one bit of magic you had to remember, you have to look at that is the sorted line. But again, and if you wanted to find the least common words, it's not going to be really helpful, unfortunately, because of the dictionary. What? Why is the? I know exactly why. But the, it says, occurs only once, even though it was also, again, it was, so it says the occurred only once. This is a weird thing. But the also occurs 7,996 times. What it is that there's actually a hidden character right here. And that hidden character is the begin the file character. So that's why that's giving me issues. So anyway, that is what a dictionary is. So that's one use of a dictionary. So with that, let's go ahead and jump straight in to your homework. Again, this for dictionaries, you really want to look at the the lecture videos that I have set up for those that I told you to watch before today. So if you didn't, hopefully this will be useful for when you do go there, and hopefully this gives you another approach for those of you who did watch those. So let's go and see how that applies here. All right. So the goal for this upcoming assignment is the Hawaiian pronunciation homework. Okay. Now Hawaiian has its own native, there's its own native language there. Again, this is another great homework that I blatantly stole from another person. Well, not blatantly stole, I credited them. Anyway, and you think like, okay, words like aloha aren't really that complicated, right? How hard, why do we need a pronunciation guide for it? Well, what about for the Hawaiian state fish? Hawaiian state fish, which of course is the reef triggerfish, but they don't call that in Hawaiian. They call it, of course, its proper name, which is humu humu nuku nuku apua. Humu humu nuku nuku apua, meaning the triggerfish with a snout like a pig. And this is actually pretty cool because there are a lot of words in Hawaiian that don't necessarily seem necessary that once you know the rules, they're very obvious to pronounce. But there's also a lot of fun words like that. So, yeah, as he puts it, works like humu humu nuku nuku apua, look like somebody fell asleep on the keyboard. It's actually an extremely simple language, though. There's only 12 characters in Hawaiian. 5 vowels, 7 consonants. That's it. 5 vowels and 7 consonants. So the goal for your homework is to write a program that allows the user to enter a Hawaiian word and give the pronunciation of the word or the words that they enter. So, for instance, we are phonetically translating humu humu nuku nuku apua to humu humu nuku nuku apu a. So there's 12 valid characters, as I mentioned, A, E, I, O, U, the 5 vowels that we have, and then P, K, H, L, M, N, and W. So let's go and learn about the language, the Hawaiian language. Consonants are super easy to understand. The only exception is the W is W, which can be either a W or V sound. So P, K, H, L, M, N, pronounced exactly like you would in English. P, K, H, L, M, N. Right? W for the start of the word is either a W or a V sound. If you see a W at the beginning of the word, we're just going to assume it's a W sound. Okay? Just for simplicity's sake. W after the letter A, it can be variable as well. We're also just going to simply say that's a W sound. So if it's at the start of a word or after the letter A, it's going to be a W sound. Same if the W is after a U or an O. So the only exception if it's a W after an I or an E, it's going to pronounce it as V. Honestly, this is going to be so far down on your considerations, this should be the last thing you implement. The vowels are very straightforward. If you've looked at Japanese, this is going to be very, very straightforward. A sounds like A, as in Austin. E sounds like as in egg. The I sounds like E, as in bee. O is O, and U is oo. O as in obey, and oo as in mood. Okay? So for this, you can actually create a very simple way to do this. Okay? So for instance, aloha should give us aloha. Now, there's a bit of a catch is when we get our digraphs, our vowel digraphs specifically, or vowel pairs. And again, if you've taken a look at Japanese or some other foreign languages, this will look very familiar to you. Honestly, what it comes down to is that these letters actually do sound the same, but when you pair them together like that, what happens is that they kind of blend. So A and I becomes A and E. So A and E. A E A E A E A E A E A E I I I I I. A and E becomes I. That's what it happens. I as in ice. A and I becomes ice. A and E as in ae, also I becomes ice. So A and I and E. A and O becomes ow, right? Ow. Just kind of blends together into one syllable. Same with A and U. E and I becomes A, and you can go through the chart yourself. But those are your vowel pairs. Yeah. So, for instance, we've got this. So, for instance, the word keiki means child in Hawaiian. The EI isn't pronounced as separate vowels. It's pronounced as A. You don't go and say keiki. You don't do keiki. It's keiki. So why the reason I emphasize this is because this is the word I will test your code on. So I will test your code on keiki. Okay? I'll test your code on keiki. And what I should see is K key. That's it. That's all I should see, right? This becomes K. This becomes key. And what I'll get for students who who don't follow the guide on this one, you're gonna get, or don't follow me in the next 20 minutes, or 15 minutes rather, I'm gonna see this, there, which is incorrect, and I'll have to tell you to go and do a lot more work. K, they will give me K, E, key, which is incorrect. I want K key. Okay. So now you know, again, Maui becomes M, Ao becomes Ow, so Mao, and then the next pair, Ui, becomes Ui. You'll notice that all groupings aren't represented. That's okay. If there's no vowel pair, then you just simply, for instance, O-A isn't represented. In that case, you just simply pronounce the O as an O and the A as an A. Okay? So you can read through that yourself on your own time. What I'm here for is the important things to help you get set up. So requirements. First thing you need to do is you need to check if your program should check if it is a valid Hawaiian word. That is the first thing first. What do I mean by that? Is that the program should check if it is a valid word. The valid characters are the valid letters, the 12 letters plus the spaces and apostrophes. If the word is not valid, yell at the user and ask for again. Spaces are breaks for word and should be kept intact. An apostrophe is a hard stop. So, for instance, A-E allows you to do A-E as opposed to I. And then ask them if they want another word. So here's the kicker. For you, if you are looking at this program, and for your first instinct might be to look through, it might be to use the replace method. Simply replace any phoneme with its pronunciation, right? Any letter with its pronunciation. You can't though, because you'd have to modify everything at once. Because if you replace your I's with E, and then you go to replace your E's, they'll become es. It's going to be a mess. Using upper and lower will change all the characters to the given case. That'll be that. So you can't use the replace method. You'll need to evaluate the characters. In fact, the standard idea where you would normally go through a word and go through letter by letter is not going to help you. Instead, at least not with a for loop. Here, you're actually going to be using a while loop. Okay. So this is example input. Enter a valid Hawaiian word. Invalid. V is not a valid character. Enter a valid word. Aloha. Do you want to enter another one? Humunu, humunu. It tells you you didn't answer yes, no, right? Here, yes. So this is just basically an example examples that you can example input output pairs you can test. Okay. So how do we do this? So let me give you some skeleton code, as it's called, because it's like a bit of basically just kind of a skeleton to build your code around. First off, you're going to want to have your work is going to be done. Don't try to do the while loop. That should be one of the last things you do. The while loop that says, do you want another word? Okay, that kind of testing input output, that should be the very last step. Instead, the first thing you should do is work on the validate function. Given a word, tell me whether or not it's a valid Hawaiian word or not, okay? Remember, pass doesn't actually, and remember, if you haven't seen pass before, that means that it basically says replace me in actual code. It just makes it so that you can run this code and not get any errors right now. Then the other half, which is the hard half, is the pronounce. If the character is valid, you pronounce it. Sorry, if the word is valid, you pronounce it. And that should basically have a output is your output is equal to like how the output is how you pronounce it, and return output. So basically, you concatenate to the output, right? Similarly, for validate, let's not use the pass. Instead, what we're going to do is we are going to say, we're going to just simply assume something is a valid Hawaiian word until we're proven otherwise, right? So pronounce the output. Now, we can't use replace. So the question is, what should we use here? What's the module we're in? We're in the dictionaries module. Okay? So first off, honestly, it's not so let's go ahead and just write down our characters here. Why? Okay, and split them up into kind of things. Cons is equal to, what are our consonants in this? I haven't done this in forever. Our consonants are, scroll all the way up, are PKHLMN. So P, K, H, ... You can fill in the rest, right? Okay. And the reason I'm just keeping these as a list is because P and K, everybody looks at those and knows how to pronounce that. You don't need a pronunciation guide for P and K and H. You see a P, you do a P. You do a plosive. You see a K, you do a K. Okay? Instead, let's look at vowels for a second. Vowels, instead, we're going to use a dictionary. Why are we using a dictionary here? Because while if I see a P, I know to just simply print out a P in my output. If I see an A in my output, what should I give in my output as the pronunciation for it? What's the A goes? What does A sound like in it? Ah. A is like ah. So A is the key, ah is the value. Make sense? So that means anytime I see an A, I can translate it to an ah. Anytime I see an E, I translate that to an eh. Except, of course, if it's a double vowel. And double vowels are things like EI becoming A. So the first thing you'll want to do is this is literally the first thing you'll want to do, which is populate all those populate the vowels, all 5 of the vowels, and then go through the table, right? Specifically go through this table, right, in the dictionary, and populate with all these, right? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's not going to take you that long at all to just simply write down all those combinations. It will save you so much time. Because if you don't use this, if you don't do this, your code will be hundreds of lines long. If you do this, your code will be 50 at most. Okay? So how am I going to do this? Well, no more code. That's how because I can only give do so much. Let's work through the example of keiki. Sorry, I'm going to go and work through first actually aloha, because that one actually has it doesn't have any double vowels in it. Okay? Okay. So aloha, we're going to build our basic algorithm using aloha. Okay? So my output is, so this is my word. It's equal this. My output is this. And we have the dictionary over here that says, you know, the way that we translate things. Okay, so first thing we do is that we're going to go and loop through this, and we're going to use a while loop to go through to go over index by index. Why will become apparent when we go over when I do the next example. So first thing is I start at index 0 and I check the A. So A is in vowels. It's not in consonants, it's in vowels, right? So I see an A, so what should I add to my output? An ah. And here's a trick, by the way. Anything that's a syllable, all syllables look like this. They are consonant, vowel, dash. Con, vowel, dash, without exception. Con, vowel, dash, right? Va, I, me, q, right? Everything is consonant, vowel for a syllable. So as soon as we read a vowel, we put a dash so that they represent that we're moving to the next syllable. So ah, so we read A, going to ah. Next, we see an L. L's a consonant. We just drop the L in, right? Doesn't require any translation. Next, we see the O. O becomes, so O, right, goes to O. So we add O to the end over here. Right, so we went through da, da, da. So we've done this, add another dash. Go to the next character, that's an H. H is a consonant, so we just simply drop it in our output. And then we go to the next character, which is ah. Okay, and we drop that in our output. And so we've got aloha, right? So A is a vowel. We know how to so we translate it, right? How did we get the ah? Right? We looked at A. We asked ourselves, is this a vowel? Yes, it is. So I'm going to use the dictionary and say, okay, given this key, what is the value? And I'm going to add the value to here. And since it's a vowel, I'm going to add a dash to it. So we got aloha. Now, one thing to note is that I probably don't want a dash right at the end of mine, but that's actually something to handle at the very end. Since you know that everything is going to be vowel, 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 right? You know, it's always going to, you can just simply leave off the last character in your output. Like once you return, right before you return it, you can just chop off that last character. Or you can be careful and say, if the last character is a dash, just, you know, slice it off with the slice operation. Now let's actually go through how the actual algorithm, now we kind of got the idea. And we're going to use the actual test case, which is K key. Okay. So I start over here. Okay? This is the key. I start over here on the first character. Okay. And I'm actually going to go through the algorithm that you should write now, which is as follows. Is this a double vowel? Sorry, is KE a double vowel? No, it is not. KE is not a double vowel. That's in my double vowel dictionary. Is K a vowel? No, it is not. Is K a consonant? Yes, it is. Okay, it's a consonant, so I read one letter. Shall I move forward one letter? Okay. Now I'm at this. Now I'm at index 2. Sorry, index 1. I look at index 1 and the one ahead because the first thing I want to do is check. The first thing I want to do is check to see, do I have a double vowel? Why do I want to check a double vowel first? Because I don't want to accidentally put out two vowels when there should be a double vowel instead. Okay? How do I check for a double vowel? Slice. If you slice, you don't have to worry about going out of bounds. So slice. Ask yourself if this one and the next letter, so right in this one, so when I went over K, I asked, is this and the next letter, is KE a double vowel? No, it is not. Is K a single vowel? No. Is it a consonant? Yes. Here I'm going to ask it, is EI a double vowel? Yes, it is. So what I do is that I go to the dictionary The dictionary has EI in it, and it says if I see an EI, I should put A in my output. I just did a vowel, so I'll also end it with a dash. And here's the key. I read 2 characters, right? It was a double vowel, so I read 2 characters. So I advanced 2 characters. That's why we're going to use a while loop and not a for loop, because then we can manually control how far we move ahead, right? Does that make sense to everybody? We're going to use, if in a for loop, you wouldn't have that kind of control to do that in Python, okay? I see, so I read 2 vowels. Now I ask, is Ki a double vowel? No. Is K a vowel? No, it's not. Is K a consonant? Yes, it is. So I'm just going to drop it out. And then I digested 1 character, so I move forward 1 character. Is I and the next character after it, which happens to be nothing, is that a double vowel combination? No, it is not. Is I a single vowel? Yes, it is. I becomes that. So K dash key, right? And that is how we, and then it's a vowel, so we'll put out a dash. And what you'll want to do, what I mean to slice off at the end, the very last thing you can do is say, if output -1 equals a dash, then output is equal to output. So you're really going to make sure you know how to use slices, okay, for this one. Once you do that, the pronounce beyond this takes about 8-10 lines. And notice I didn't care about it being a V or a W yet. That's something you add in at the very end, kind of because it's kind of an edge case. But it follows the kind of same idea, which is you check to see if this character and the next character. So you cannot do this. You cannot do 4-letter. You cannot do this, 4-letter in Word. You cannot do this. Do not do that, right? I typed it out. Do not do that. I'm typing out and saying it is wrong. Instead, you do this. You do it the manual way, which is index is equal to 0, while index is less than length of the word. And then you have to increment the index manually, right? All right, so I realize I've gone over time. Sorry about that. But I just want to make sure that basically you got the tools to succeed for this one. Again, validate over here. I'm going to go ahead and drop this in Discord. So I will see you all on Tuesday.